Welcome! In this video, Keith KB3TCB talks about mesh networks and the future of amateur radio.
All right. The reason the mesh is important, if you want one word that says why the mesh is important, it's this word here, redundancy. And you'll see why that's the case. That's the most important thing about the mesh. The next thing is, to be honest with you, except for HF, I think all radio is going to be TCP based. And I usually tell people your cell phones were analog a few years ago, and then they started getting digital, and then now they're TCP based. And that same progression you've seen in your cell phones is going to happen in all radio where it can happen. Anything, I'd say anything at 70 centimeters or 220 high, it's where it's going to go. And there are reasons for that. They're not just technical reasons, and not just you want to hook it to a computer. It's because bandwidth is one of the most valuable resources we have, and it's going to get squeezed and squeezed and squeezed. So things are going to have to get digital. Okay, now this is one of the things that amateurs can bring to this. If we get a network out, several networks, many networks, and the amateurs have repeaters, and I'm using the word repeater here, then we are a group of people that have the knowledge, and it's out there. People will rely on us for it. That's very important to us. The next one is the only political state in my whole presentation. I absolutely support a change in the rules that say the FCC says gives you your frequency and your bandwidth, getting rid of everything about modes. I think that's the way things have to be for us to move forward. The implementation of modes in the laws stop us from making progress. One example to me is I would love to do this digital stuff at 70 centimeters, and I can't do it because they've said the modes that are available. When I say there still will be people that give modes, that'll be the ARL or your organizations, but I don't think that's FCC's job. Okay. The next thing is that I've had people react to this about, I'm talking about a mesh. There are a lot of different kind of networks, bus, ring, star, tree, mesh. There is nothing sacred about any of them. In the real world, it's going to be a combination of whatever works. It's that simple. So people want to put up backhaul microwave systems using this kind of technique. That's great, because we're going to need them. People want to put up the mesh. That's great. We're going to need that. So there's nothing sacred about that. The other thing is you go to this address, remoteamateur.com. Everything I know about this is on that site. I put all the links there, and this presentation I will put there as soon as it's over. Okay. All right, but this just shows you what I meant by bus ring. And you can see by the configuration, the line, the ring, the star, a mess, and a mesh, the way that works, the different networks. Now the one I'm talking about over there is this one here. But any real world network is going to be a combination of all of these, or not all of them, at least two of them, I would say, without a question. Okay. No. All right. Now this was my dream when I started. I live in Frederick, here. I wanted to communicate with Hagerstown. I got two mountains that would allow me to do it. And I'd like to get down to Rockville. And it was Vic and Kevin and David who says, okay, I've got to get down to Rockville to these guys. They've done it all before me. So that was my dream about that. And I won't go into the details too much, but you can see there's a real mix of equipment, radio equipment. When we were talking about you were interested in remote amateur stuff, that could be combined with it. Any of the digital things can be combined with it. I think, you know, if we got the other digital modes to hook to it, you got to get it all integrated in one thing, with this kind of being part of a backbone system for it. Okay, now when we come to why a mesh, what's special about a mesh? Okay, these are repeaters. I'm using the word repeaters here. So think of a repeater, which you all know well, and you hook a computer to it and change the way it works. That is a router. A router is nothing but a repeater, okay? It's got a lot of automation in it. So you've got repeaters around here, and I'm hopping between this repeater. And what happens? It breaks down. So this repeater broke down. Can't get to the next repeater, okay? What happens in a mesh? I've got a bunch of other repeaters. It chooses a new repeater and goes this way. That happens completely automatically. You don't know about it, you don't care about it, it works. And that's why I talked about redundancy. Each one of these things is redundancy, and it will choose the way that works, period. That's the whole strength of the idea. All the problems you have today is saying, I've got to link to this repeater, and then I've got to link to that repeater, and I've got to unlink to the repeater. All of those things disappear in the automation. And you gain a tremendous amount of that. Okay. I just wanted to list these up here because I know a lot of you are familiar with the digital modes and sort of a progression here that you can see. And we keep them all. I don't know, I haven't been too much in all of these, but none of them disappear. And so the goal here would be to try to take these that are applicable and hook them to the mesh. They won't disappear, they'll be part of it. And the people that are good at those, there's room for every one of them. I mean, the mesh is not going to work at HF. You're going to have something to complement it there. So it's really important that we work on that end too. But it's not enough to do that. We also got to continue on up at 70 centimeters. And so the last one down here is the mesh representation. Okay. Now, the way I'm calling this, is it amateur radio? Is this a computer geek thing, or is it amateur radio? This is strictly amateur radio. It's RF. That's amateur radio. It uses a repeater. That's amateur radio. It has all the problems and issues of propagation. That's amateur stuff. It's communication. Okay? This is what amateurs have been known for in emergency communication all along. We're good at that, and that's what we're still going to be good at that. It's digital. Okay, now we're beginning to wonder. The future is digital, so if amateurs are going to have a future, they've got to get on the digital bandwagon. Okay, the other thing is the internet. Everybody knows what that is. It's like universal. This transition we're talking about brings the amateurs into that world, and I'll talk more about that. And you're going to have to learn this technology. It's simple. I can promise you. This. Okay, now I said it's a repeater. This is really important. It's a repeater plus plus. As you look at this repeater, you'll see over here where the antenna is on this side.
I have to get that.
All right, typical antenna, amplifiers, all amateur stuff. Then you go over to your receiver. You got a receiver here, no more than that. You come up here to your transmitter. You got your oscillator and your frequency control. You got your PA, your final amplifier, and then you're back to your antenna. So this is just a repeater. So what's the difference with the repeater? Now I love them. They're fantastic with your tones. So you have to know the tone of the repeater. I've never figured out how people know that. By some magic, you know that. Okay, so what you do here is you have a D to A to converter and you have an A to D converter, because you're going to speak into a mic. It's audio, but we're going to talk to a computer. So we have to have something that changes a digital signal to a analog signal. So this is the first step that makes a computer. Everything over here was just a standard repeater. The next step is we're going to hook it to a computer. Because I mean, you could stop here and just have digital radio, but we're going to hook it to a computer. And what this whole section does is just give you these cables. That's all that about, because we want to be able to put it over this cable. So these are the two new things that you add to that repeater. And what does this give you? It gives you automation. You don't have to know your tones. You don't have to know the call signs. You don't have to know all this stuff you have to know. You don't have your repeater you have to look up. And I'm sure a lot of you today start looking in your cell phones or on the computer to find out what repeaters you can use. All that is sort of built into the system. So this is just a repeater, nothing else. Okay. Now, I just listed them again. This is exactly what we had before. This is the new stuff. Now this is where it gets important. Now you probably all understand some form of digital modulation. There's nothing secret about that. TCIP is just that wire. I don't think anybody in here wants to know a lot more about that. I know I don't. Okay, it works. Now these are the interesting things. Now what I haven't done, which I should have done here, is translate these to something you know. You all know collision management. You all know to listen on your radio first and see if someone else is on the band. All this does is automate it, because you're not going to be there listening with your ears, so you don't know. So this automates that. The network management, if you've ever tried to use D-Star, which I won't say anything there. If you try to use D-Star, you've got to find out who do I want to talk to, what call sign do I have, how do I connect to them, how do you manage your contacts? And you probably have a lot of you use logbooks, so if you put your logbook in here and you put your listening to see if you've got collisions, you've got that, and that. Probably a new thing is security. Okay, we don't have any security in the amateur world except to try to find out who in the world is messing us up. Okay, so these are some of the new things that the digital world gives us. Now, what is a mesh? All right. I think it's important to realize it's a collection of repeaters that are hooked together by a computer, okay? You have a wireless network. Think of your repeaters again. You got speed because of the higher bandwidth. We've got a lot more speed, but that's only because of the bandwidth. We're in the microwave thing. These three things here are what really makes it interesting. I showed you earlier how one of the repeaters broke down and shifted to another one. That's the crux. That's the whole thing. It's as simple as that. Because of that, there was a gentleman that came here and put these on the table, and put this one on the table. There's one back there, and there's one over there. When they walked into this room and plugged these in, they connected to the switchboard. I didn't have to do anything. They connected over there. It popped up on his screen. If this one came in, it popped up on his screen. This one came in. I can unplug this and walk out of the room, and they're just going to resend the things differently. So if someone was sending from this one to this one to that one, and this one disappears, it'll pick another one and do it. All automatic. And that's what gives it its reliability. Because there are a lot of them, and they switch between them completely as necessary. Every repeater remembers who it's talked to. It remembers how well it talked to them, and says, well, this guy's I'm not doing very well with, I'm going to try this one. So there's a lot of stuff behind that. Okay, completely automatically, that's the fault tolerance. If it fails, it takes another round. Really, the basics of that. Okay, now HSMM, this was started by if I've got it correct, I'm not sure, the people down in Texas. And when the ARL decided a while back that they needed to figure out what was happening in the digital world, and they set up their committee, and a lot of people that were involved in that started doing things. So the people down in Texas did a lot. And it's important about this mode business. And that's what going back to this idea that the concept of modes is sort of going to disappear in one sense. It's not going to disappear in HF. It's not going to disappear in all the present digital modes that connect to this. But once it's on the network, it's digital. So I can do anything with this. Voice, video. If you look back on the middle desk, there's a camera. This camera here, it's watching everybody. It comes up on that monitor. The voice over by IP. I can go pick up that telephone and dial the number of that telephone and talk on it. It's digital, it's voice over IP. I don't have these things implemented here, but email, file transfers, all these things are really simple to do once you've got the TCP network there. And the people that are doing, for example, emergency communication, they want to be able to do all the things they did when the internet was working fine, when the cell phone towers were working fine. And just because those things disappear, they don't want to have to go back and say, hello, how are you, what are you doing? They want the same stuff to go back and forth. And that can happen here. Okay. All right, what about the spectrum? This one, this unit down here, right here, is a 2.4 gigahertz. I'm going to use a repeater all the time. If you want to use router, you can, but I'm going to just call it a repeater. 2.4 gigahertz. We share that with the industry, which I'll talk about more later. We are in the part 15. We're in the licensed part of that. I'm still talking about 13 centimeters, and I will explain this to you in the next slide coming up. Okay, the yellow part is the amateur band. The blue part is the whole ISM, which includes the amateur band. These are the 14 channels, 2.41 gigahertz to 2.484 gigahertz. These are in the amateur band. So we can't use this one, we can't use any of those, we can't use this one. We can use all the green ones because they're within our band. If we're in the blue section, we can run 100 milliwatts, legally a maximum 1 watt, okay? As soon as you get in this here, what would be yellow, I can use a minimum of 200 if I want, but I can use a whole 1,500 watts here if you've got the money to do it. Okay, so now why are these two top ones important? They are not overlapping. You see how these all overlap? These do not overlap. So the equipment that you're seeing tonight uses these channels. And it does spread spectrum. The system will automatically do spread spectrum. But when you put the software in here, which the people in Texas developed, you tell it, only use this channel, for example. You can say also only use this one. So these machines here are now using just this. We're not using spread spectrum. It's a one channel, which means we could do 1,500 watts if we wanted to. As soon as we use both of them, we can almost 200, but that's another story. Okay, so this is the spectrum I'm talking about, and this is the amateur section of it. This is the frequency. It's microwave, with all the pluses, and I should say a lot of minuses for microwave. Okay. All right, this is the problem. You have to have line of sight. And I'm not just talking about line of sight. not only do you have to line of sight, you have to have this zone around it that's not blocked. Okay, which I knew absolutely nothing about when I started this. Leaves will stop it, walls will stop it. I'm sure in your house when you put up your router, you said, well, it worked good in that room, but it didn't work good in this room. We're talking about something that's not really very strong. Now these routers are only about 100 milliwatts. And so anything we do here for any distance is going to be probably, a watt. But you can't put amplifiers in it. But that's, we'll talk about that. Then so the idea is you need a tower, okay? So people want to go around and put 120-foot towers. We're not going to be able to do that. So you're going to have to find high places to put antennas on. And so I think the biggest challenge to us is getting repeaters on top of water towers and hospitals and schools or any high structure around. Because what you've noticed is high structures have become very valuable for antennas. Every high thing is packed with antennas today, and we're not there. We have to get there. The only way we're going to get there is to do this. So to get that real estate, which is very valuable on top of high places, this will help us do that, okay? All right, power levels, I mentioned it a little bit. Maximum 1 watt in the Part 15 rules. In our rules, you can go up higher depending on the spread spectrum. This really isn't important. I mean, you either see it and you can reach it, or you can't see it and you can put as many watts into it as you want. You're not going to get there because you've got to have the line of sight. So the watts is not really the issue here at this frequency that we're talking about. Okay. Now, I want to mention this, that we're talking about here tonight mostly, except for this unit at the top. This top unit here, this one, is in the 570 band here. Okay? So this is where most of your routers are going to be. And you'll see why I talk about this later. This I find very interesting for people that want to follow it. I think everybody should get out and read about TV white spaces. And all the TVs were voluntarily moved to other frequencies. That frequency band was left open. Look at this. This is 470 megahertz. People are making routers today that work on 470 megahertz. They're not going to give you great bandwidth, but you might get 3 megabits bandwidth at that frequency. And I'm sure that amateurs can make this kind of equipment work inside of our band, if we're allowed to, okay? So I think we can go, I mean, inversely, we got a very wide band here, and it gets narrower and narrower and narrower. I'm hoping we'll be able to get down to work on this place, in this area. I see a future there for us. That's good, okay. Scenarios. This list could take, I mean, I could fill up pages with it. So I've just written a few things here about disasters. Obvious. Video is obvious when you see and you'll see that later in the presentation with the camera. The telephone you see is obvious. That works very fine. Remote monitoring, I haven't done it, but people started using this to monitor their repeaters or monitor other things. People put it up to monitor things at home. Another area which you'll find on the web very much is like marathons and bicycle races. It's not just the guy standing with the HT or the HT there. They'll put up one of these cameras and actually see the whole race presented that way. Repeater linking is going to be something I think this can take up, a different way of doing the backhaul from a repeater. Obviously, you can send any data over it, so this is a data area you can do. And then we'll come to that we support these groups, but that'll mostly be in another presentation. And that's with the digital. So now you're listening to this, right? Okay. This is just a list from the other point of view, not where we are in racings and bicycle things, but what goes over it. I've mentioned it before. And the people here can go look at that table back there later in the telephone and see, what it is physically. I think most of this will be pretty clear to you, but you can ask me questions. I don't know anything about this. This is about the emergency communications group. One of the things I think that I haven't dug into, which I want to, is the actual software that emergency communications people use that can be used for this system, but that's another story. And some of the people here, I forgot one of the gentlemen in the back has some interesting software in his unit. Okay. Now, this is a very important slide. At these frequencies, we have a lot of bandwidth. Look at these speeds, okay? 0.0012, 0.003, 0.056, D star, 0.128, okay? Here, 5, okay? The maximum of the unit that's back in the corner there is 45 megabits. There are units that give over 300 megabits. I'm not going to say that we're going to be able to do that, but we can beat all of these things very easily because we're microwave. There's nothing magical about this. When you get a microwave, you've got a very large bandwidth, and you can do a lot of this stuff. Okay. Now this is the politics of it, which I mentioned earlier. I would like to see, now don't hold me to these numbers exactly. I would like to see you regulate these by saying the bandwidth of your signals. That's it. I think the FCC should say this and nothing more. If you want the ARRL to say something more, or if you want your club to something more, if you want to say this band is for TV and this band is for FM, and the clubs and the ARRL should do that. That's not FCC's business. The FCC should just tell us our technical thing. On these bands, you can use any technology that meets this. On this band, you can use any technology that meets it. The only way we're going to keep up with the future is if we have flexibility here. The reason I can't do mesh on 70 centimeters today is not a technical thing. It's because they only say I can do ATV with that band. So those rules are stopping us from doing the things that need to be done. And changing the rules won't stop us from doing any of the things we're doing, because you'll still be able to use it the same way you can today, but we will also be able to do more. So that's the end of that speech.
Well, we hope you enjoyed that terrific presentation by Keith. If you have any comments, please post them on our YouTube channel. Thanks again for watching, and this is Alex, W3JAG, saying goodbye for now.